So in this video we are going to learn about the cells in parallel. Cells in parallel. So in initial case we take all the identical cells. Okay. So cases all the cells are identical. Right, identical cells. So we'll draw the diagram. This is one cell. This is internal resistance E R. Another cell. We draw three cells. Now one external resistance is connected across this. So R is the external resistance. So this cell, you can say the C1 cell, this one. Draw the different colors so that you can understand easily. This is the cell C1. This one is the cell C2. And this is the cell C3. So all the cells having same EMF. That means here is also E, R, this is also E, and this one is R. Now what are you going to find out? You are going to find out the effective equivalent cells. That means instead of these three cells, we are going to connect only one cells. So what will be that cell's EMF, and what will be the equivalent, what will be the internal resistance of that cell. So remember this one. Since the cells connected in parallel, so the total EMF of all cells will be equal to the EMF of a single cell. Okay, so you can write down here. Since cells are connected parallel. In case of parallel, it only happen EMFs will be all the same. So the total EMF of all cells will be equal to the, we can say total EMF or the total that is the parallel combinations. Okay, total EMF in parallel combination is equal to EMF of a single cell. Okay, so what is the effective EMF? EFF means the effective EMF. Okay, that means instead of these three, we are going to connect the another cell whose EMF will be this one, so it will be same. Now what is the equivalent internal resistance? See, all the internal resistances are connected in how much in all the parallels. Okay, so say the m number of internal resistances are there. So now the equivalent internal resistance internal resistance of m number of cells connected in parallel. So formula will be R 1 by R effective is equal to 1 by R plus 1 by R plus 1 by R and up to m numbers. So you can write down this will be m by R. Okay, so R effective will be equal to R by m. So this thing is going to happen for the internal resistance. So total internal resistance will be R by m and the total effective EMF will be this one. Now this R by m and this capital R, this is the external resistance is connected. Now it will be connected in in series. So this circuit, this thing will convert into this one. So in this case the current is coming in this way. So battery minus is this side, so the current will go in this direction. So draw the equivalent circuit of this. You can see now. So I, this current is going also in this direction. I is, this one is E effective. E effective will be also equal to E and R by M. R by M. So this is the equivalent EMF. Total cells connected. Instead of this three, I mean this one. So now what is the total current? What is the current actually? Current flowing in the circuit. So current, the current flowing through the circuit, I have to find out the current flowing through the circuit will be I, will be the total EMF. Total EMF is E and the total resistance. What is the total resistance? R plus R by M plus R. So R by M plus this capital R. So you calculate this one, you will get ME by R plus MR. So this is the I. But remember this formula. I is equal to, so we write I here. So I is equal to this one. Now some cases are there, special cases. What are the special cases? So normally two cases already we've taken earlier also. If R value is much more greater than R, so what will happen? If R value is much more greater than R, then R by M will be neglected. This R by M value will be neglected. So we can take R by M plus R is equal to R, because it's almost equal to R, this symbol. So now current will be how much? So current I will be ME by MR, or you can say E by R. E by R. So E by R is the current due to a single cell. You can take current due to a single cell. This is the E by R. Now, therefore, the such arrangement of the cells doesn't have any significance. You can write such arrangement has no significance. Okay, such an arrangement of cells is of no significance. There's no use of this one. Okay, so normally what you have to do, you have to make R is less than this one, R by M. So R smaller. So that is why. So next case we go. Case number 2. If R is much more less than small r, then R by M plus R will be almost equal to what? R by M. In that case, I will be E by R by M. So that means M E by R. So current will increase in this case. So if I is equal to like M times the current due to a single cell. Okay. So I is equal to what? So M into the current due to a single cell. Okay. So in order to get large current in the circuit, the cells may be connected in parallel to a small external resistance. Okay. So if you want to increase the current in the circuit more, so you have to do this type of connection. So in order to get a large amount of current, you can do this type of connection. Okay. So what will happen? A small external resistance will be connected. So in order to get a large amount of current, cell may be connected in parallel with small external resistance. Okay. So today is this one. Up to this, the next class we'll discuss about the cells, different types of cells is connected in parallel. Okay. So thank you very much.